So our next topic is SIC bar XC machine architecture. We already discussed about SIC machine architecture, okay? And this is the extended version, or XC stands for extra expensive. Likewise, we can say. So in this machine architecture, the memory is 2 raised to 20 bytes, larger memory than SIC machine architecture. So you can expect the changes to instruction formats and addressing modes, which is used in SIC. Okay, and in the case of registers, there are additional 4 registers are used. We have already studied about 5 registers at SIC machine architecture, and including that 5 registers, we have another 4 registers which we are using in SIC bar XC machine architecture. Which are the registers? The registers named as B, S, T, F, and base stands for base register, and which is used for addressing. Okay, and S and T are there is no special use for S and T register. This is termed as general working register. And F is the floating point accumulator, or floating point arithmetic operations which include floating points. We use floating point accumulator, and it is of 48 bits. Okay, apart from or additional 4 registers are used in SIC bar XC machine architecture, and the registers are B, S, T, F. F stands for floating point accumulator. Then the data formats. Okay, we already discussed the data formats for integers, for negative values, or for characters. We have used ASCII values for ASCII values for storing characters, and also for representing negatives we used 2's complement, and for representing characters we used another format in SIC bar XC architecture. In the case of SIC architecture, in the case of SIC bar XC, we already noted that a floating point, we have a floating point representation in SIC bar XC machine architecture. For the representing floating point, the data formats is, we have S at the first, S, then exponent, then fraction. This is the data format for representing a floating point data type in the memory. Okay, and the S stands for if the fraction, or if the floating point data is negative or positive. If it is a positive value, S get the value as 0. If it is a negative floating point, S gets a value as 1. Okay, then the exponent comprises, and exponent uses 11 bits, and the fraction part use 36 bit. This is the data format for storing floating point data type in the memory. And the next is SIC bar XC machine architecture instruction formats. We have 4 types of instruction format. They are format 1, format 2, format 3, and format 4. Format 3 and format 4 are somewhat similar, and they are differs in case of E. In case of E എന്ന് പറയുന്ന ഒരു പോയിന്റ്. Okay, in case of, if the value of E is 0, it is termed as format 3. If the value of E is equal to 1, it is termed as format 4. Okay, format 1 comprises of only or it uses only 1 byte memory. It only stores the opcode. Okay, and in the next format, that is format 2, uses 2 bytes of memory, and the 8-bit used for opcode, for storing opcode. Opcode means what? Opcode means the instruction or the operation, which is the operation that we are used to for performing some actions. So that is the opcode. This can be, and this operation can be converted into a machine language, and that code is stored in opcode. Okay, then in format 2 we have another 2 registers that are R1 is the register 1, R2 is the register 2, and some values will be stored in R1 and R2, and that each registers uses 4 bits in order to storing register 1, in order to storing values in register 1, and 4 bits for another register. So total 2 bytes. Okay, then format 3, and the 6 bits are used for storing opcode, and another 6 bits are used, 6 1 bit each are used for indicating different types of registers. Which are the registers? N is, we use N, I, X, B, P, E. N stands for indirect register, I stands for immediate addressing, and X stands for indexed addressing, B stands for base register, and P stands for program counter, and E is the what unique type value which indicates whether it is a format 3 or format 4. And then we have displacement or DISP at the rightmost end of the format 3 format. Okay, then what does this N, I, X are used for? We already discussed. N stands for indirect addressing. Indirect addressing means we will be not able to get the exact value or exact location of the value which is stored in the memory. We have to go through some indirect access to in order to get that particular value. Okay, the next one is immediate addressing. For example, if we are adding two numbers and we use the instruction add R1 and R2, if R1 contains some of the addresses, or if the R1 is indexing to some other locations, and that location may point to another location in order to get the exact value for register 1, or the exact value for exact operand that we are using in order to perform the addition operation. So the next register R2 may contain the value itself. That means we get the next value or the second operand immediately or directly from the from the register R2. That type of addressing or that type of getting values is called immediate. For that purpose we are using this register or this type of addressing, that is immediate addressing. Okay, then the X we already discussed in the SIC architecture. S is what, X is what, indexed addressing. Indexed addressing means we are indexing or we are using another addresses in order to get the exact value. Then the next one is B. B stands for base pointer or base addressing. Base addressing is what we are storing some of the base addresses or from where we are starting, and we need to store the base address in order to start that particular instruction or operation. Okay, then what program counter means if you are setting some value, we know that program counter register is used for what, is used for getting the address of the next instruction that is to be fetched or that is to be operated or that is to be performed next. Okay, then displacement, displacement is used in order to get the exact location or target address. We are representing or we are telling it as target address, that is TA. In order to get the target address we use DISP. That we will be discussing in the later part. And the format for the same thing is that each addressing mode is comprises or using only one bit in order to store that particular values. Then in the format 4 we are using 20 bit in order to store address of the particular instruction or particular operation that is to be fetched. Okay, and the format 4 uses 4 bytes of memory and 20 bytes are used for storing addresses of the operands. Okay, then according to this addresses, the values of the addresses may change. The values of the addressing, that is NIX BPE, the value may be 0, value may be 1. Based on that values, we are classifying the addressing mode into different types. That addressing modes are base relative addressing mode, program counter relative, direct addressing mode, immediate addressing mode, indirect addressing mode, indexing addressing mode, and extended addressing mode. Okay, base relative addressing mode is what? There is at the bottom of this slide you can see indexing cannot be used, a not, that is what indexing cannot be used with the immediate or indirect addressing. That means we cannot use immediate or indirect addressing in order to index or in order to get the values through indexing. So we always putting the value of n and I. N stands for indirect, I stands for indexed, I stands for immediate. That n equal to 1, I equal to, we always set that value for n and I as 1, because in case of immediate and indirect, we may change, because that is the addressing mode. In other cases, indexing cannot be used with indirect or immediate. Okay, then apart from indirect and immediate addressing mode, these two addressing mode, we can have the value for n and I equal to 1. That is same for all other type of addressing modes. Okay, we will be discussing each one in detail. What is base relative addressing mode? So we already told, or we already noted, indexing cannot be used with immediate or indirect addressing. So we are always putting the value for n and I as 1, apart from indirect and immediate. Okay, then b is equal to 1. If we are using base relative addressing mode, the value of b should be 1, and the other values, that is apart from or excluding n and I, the other values are set into 0. Okay, the value of p should be 0. Then what is program counter relative addressing mode? In that case, p, the program counter, value of the program counter is equal to 1. The others are set into 0. Okay, excluding n and I. N and I, the value for n and I will always be 1, because we are not using indexing, or we cannot use immediate or indirect addressing, that is n and I, for indexing. Okay, because we are getting the value or the exact location of the values only through addressing. Okay, address not by exact values. So in case of immediate addressing, we get the value itself from one of the registers. That's why we call it as immediate addressing. So addressing or indexing cannot be done with immediate. Same is the case with indirect. Okay, then what about direct? In direct addressing mode, the b and p equal to is set into 0, because b stands for base relative, p stands for program counter, n and I is always 1. So that is all about direct. Okay, then immediate addressing mode, in that case only I equal to 1, because that stands for I stands for immediate. So I is set into 1. All other factors such as n is the indirect addressing mode, that is set into 0, because only through this type of addressing we are getting the values, because one of the registers may contain the value itself. So we are using immediate addressing mode in order to get, or in order to perform that particular instruction, or in order to complete that particular instruction's execution. Okay, so I equal to 1 is set, x equal to 0, x means the indexed addressing, that is set into 0. Okay, Then indirect, then the next case, indirect addressing mode, n equal to 1, then all others, I equal to 0, x equal to 0. In case of immediate and indirect addressing modes, we are using what? Three values. Which are the three values? N value for n, that is indirect addressing, value for I, that is immediate addressing, value for x, that is indexed addressing. Okay, indexed addressing cannot be, we already told that indexing cannot be done with I, immediate and indirect. So the value for indexing, that is the value for x, should be 0. Okay, in case of immediate and indirect. Then what about indexing? Indexing, both n and I equal to 0 or 1, but the value for x always will be 1. Okay, the value for x will be 1 because it is indexing addressing mode. That means for indexing addressing mode, we use the register x. So the value for x should always be 1 in case of indexing addressing mode. So what will be the case for n and I? N and I may be 0 or 1. That's not the case. Okay, because it is indexing, always the value for x should be 1. Then extended equal to 1. That means format what? Format 1, format 4. So these are the addressing modes that we are using in SIC bar XC machine architecture. So if you are asked to write SIC bar XC machine architecture instruction formats, you have to separately indicate format 1, 2, 3, 4 and how many bytes are used in order to represent it. And you have to draw this figure, and you have to explain in detail, or you have to mention about addressing modes, which are the addressing modes used in SIC bar XC machine architecture. Then this is the base relative addressing mode. We are explain it in detail. Okay, in base relative addressing mode, you can see what we already discussed. In base relative addressing mode, the format should be like this: opcode, then NIXBPE. That is the sequence of the registers that we are using in order to use base relative addressing mode. So you have to by heart it, NIXBPE. Okay, and the order of the registers NIXBPE. The order may change, that not the case, but you have to by heart it. Okay. Then what is the in base relative addressing mode? The value of base B should be 1. Okay. The in base relative addressing mode, n equal to 1, I equal to 1, then B equal to 1. That is base relative addressing mode equal to 1. P equal to 0, that is program counter equal to 0. Then how we get the target address? Okay, how we get the target address? Target address is calculated as the bracket B. B means B is the base register. We have already mentioned in the registers of SIC bar XC. B is the base register. Okay, in base register, the contents of the base register plus displacement is calculated as the target address. What is the target address? We want to get the target of, or the address, the exact address of the operands that we are performing or that we are using in order to perform a particular action. We need to get the target address. That target address is calculated as the contents in B, the contents which are used or which is there in base register B. The contents is that's why we have used B in brackets. B in bracket means the contents in B. B plus displacement. Displacement value lies between 0 and 4095. Okay, then this is all about base relative addressing mode. We already discussed what are the addressing modes. In base relative addressing mode, the value of B is 1. Okay, then all other values, n is the indirect addressing and I is the immediate addressing, that is always 1. That I've already discussed what is the reason for that. Then program counter relative addressing mode, the value of p should be 1. So ni, as always, the value is same 1. We have used the value for p as 1. What about the target address? The target address is what is the program counter, the content in the program counter plus displacement. Displacement is some of the address which we are used in order to get or in order to reach the target address. Okay, then TA equal to PC plus displacement. That is all about program counter relative addressing mode, and the displacement value lies in between -2048, that is the address. How the address or displacement address may varies in case of program counter relative addressing mode. In case of base relative addressing mode, the address lies in between 0 and 4095. In case of program counter relative addressing mode, the displacement value lies in between -2048 to 20 plus 2048, because we have used how many what displacement in order to store a displacement, we have used 12 bits. Okay, then that's the address range. What about direct addressing mode? In direct addressing mode, all other B and P should be 0. Then target address is the displacement address itself. Okay, we don't need to go to another registers and take the contents of the registers. We can get, for that is why we call it as direct addressing mode. We can get the direct addressing mode from the value of displacement column itself or displacement box itself. Okay, and the value lies in between 0 and 4095. That is the direct addressing mode. In direct addressing mode, we get the target address equal to displacement address or the displacement value. Then if it is 0, if it is 1, that is indexed addressing, direct addressing. Okay, if in the case of if x is equal to 1, that means we are using some other addresses in order to get the target address, or in order to get the exact value, we need to calculate the target address as TA equal to the values or the contents in register X plus displacement. That means we are using some other indexing method in order to reach the target value or a target operand or the address of the target operand. Okay, in order to get that particular address, we are using, because we are using some of the contents in X. Okay, X, the contents in register X plus displacement, because it is indexed as it is given that X equal to 1. So we are using indexed addressing mode. Okay, in indexed addressing mode, we are pointing it into another addressing mode, another address, then only we can get the exact address of the operand. Okay, so we need to add that register plus the displacement address. Then what about immediate addressing mode? In case of immediate addressing mode, the value of I stands for immediate, I equal to 1 and all other n equal to 0, x equal to 0. X equal to 0 means we cannot use indexed addressing in case of immediate addressing mode, because we get the exact value or the operand from the register itself. So the value is n equal to 0, x should always equal to 0. Then in this case, the target address equal to displacement itself. Then what about indirect addressing mode? In case of indirect addressing mode, IN stands for indirect addressing mode. So value of n should be 1. Okay, all other values are 0. In this case also, we are using the contents in displacement. Contents in displacement, not the address. We are getting the contents in displacement. That is indirect addressing mode. Okay. Then what about symbol addressing mode? In case of symbol addressing mode, we can get two addressing modes. In case of simple addressing mode, that is SIC standard. In case of SIC and SIC bar XC, there are two types of simple addressing mode, or two ways for representing simple addressing mode. What about simple addressing mode? The value of I equal to 0, n equal to 0. That means the value of immediate addressing equal to 0 and indirect addressing equal to 0. Then what about the target? B, the base register or program counter or the value of E or displacement. That should be the target address. What about in SIC bar XC? In SIC bar XC, the target address should be displacement itself. So that is the difference between the machine architectures. In SIC standard, we are getting the target address from base B, from program counter P, or from the value of extender, the value of E or displacement. But in the case of SIC bar XC, we can get the target address from displacement itself. Okay. Then for format 3 and 4. For formats 3 and 4, immediate addressing mode, that is n equal to 0 and I equal to 1. If we are using immediate addressing mode, the value of I should be 1. The target address is used as the operand. So the target address is used as the operand. We already discussed what is immediate addressing. In case of immediate addressing, the target is the operand itself. The target address is used as the operand. That operand we can directly get the operation, or we can directly do the operation from the immediate addressing mode, because we can get directly the target address from the operand itself. What about indirect addressing mode? In indirect addressing mode, the value of n equal to 0, so the value of others are 0. In indirect addressing mode, the value of n equal to 1, the value for others are 0. So I equal to 0. Then the word at the location given by the target address is fetched. So in indirect addressing mode, from where we will get the target address? In indirect addressing mode, the word at the location given by the target address. The location, the address at the word, because we know that 3 bytes are together, 3 bytes we call the word. Okay, the value contained in this word, if the 3 bytes, the sum of the value may contain in this word, is then used at the address of the operand value. In case of indirect addressing mode, the target address can be obtained from the word. Word is the is indicated by 3 bytes. Okay, it is the location of the target address. So we can get the target address from the value which is contained in this word. Okay, then what about simple addressing mode? Simple addressing mode, the target address is taken as the location of the operand. So it can be seen in two ways: SIC bar XC, SIC or SIC. Target addressing is taken as the location of the operand. In immediate addressing,